So 24.1, 2, and 3 is a review of some work on linear equations that you would have done in earlier algebra courses, but I just wanted to do a little review of those and make sure you have the language that you need. So a system of equations is a collection of two or more equations, each containing one or more variables, and the variables are linked in the two equations. So whatever number x is in the first equation, the same number in the second equation, and the same with the y. And you can have as many equations and variables as you like. So in fact, once we start getting more and more variables, a lot of times we call them x sub 1, x sub 2, x sub 3, x sub 4, and so on, so that there's no limit to how many variables you can have. So a solution of a system of equations is all the values for the variables that are solutions of both equations in the system. Each equation is the same meaning as for both. So to solve a system of equations means to find all of the solutions of the system. So in this first example, there's one solution when x is 2 and y equals 1, and we state that as an ordered pair 2, 1. So we need to check and make sure that is actually a solution. So we have 2 times the x is 2 plus the y is 1, and that does equal 5. And then we have negative 4 times the 2 for the x plus 6 times the 1 for the y, and that equals negative 2. So we have verified that 2, 1 is the solution. And if you recall, we're looking for the intersection point of two lines when we're doing this. So if you find one solution, there can only be one solution because two lines can only intersect each other at a single point. Okay, then the second example has three variables, and the solution is x is 3, y is 2, and z is 1, which gets written as the ordered triple 3, 2, 1. So once you get past 3, there's not a fancy name for this guy. It's called a 4-tuple. And so on. So if you have n numbers in there, it's called an n-tuple. Okay, so let's verify that this is a solution to this system of equations. X is 3 plus y is 2 plus z is 1 does give us 6. 3 times x is 3 minus 2 times y is 2 plus 4 times z is 1 gives us 9. And then we have x minus y minus z equals 0. So again, we have verified that this ordered triple is indeed the solution to this system of equations. And again, if you find a solution, it's the one and only solution, because in this case where it's three variables, it's the intersection point of three planes in three-dimensional space. So notice that we're just talking about linear equations in this section. We will talk about nonlinear a little bit later. But linear refers to straight lines. So notice that this system of equations is two straight lines, and we're looking for the point of intersection of those two straight lines. As soon as we say nonlinear, then we're allowing any kind of shapes in. So in fact, hopefully you recognize these shapes as an ellipse and a hyperbola. And you can find these 4 points of intersection using similar strategies as solving linear equations. So hopefully you learned how to solve the systems graphically, because this is usually the first way we do it, because we really want to reinforce that idea that you're finding the intersection point of two lines. Okay, so let's write this equation of the line in slope-intercept form and get y equals negative 3x plus 7 halves. So I'm going to use a scale different than the one that's marked on here. I'm going to let every two boxes equal 1 because I like not guessing where the middle of a box is. So we're just ignoring the scale that's printed on here. We're going to have 1, 2, 3, and so on. So 7/2 is 3.5. So I go up to 3.5, make a dot, and then my slope is -3. So down 3/1, down 3/1. As long as the scale on the x and y is the same, you could just count boxes for your slope. So here's my first line. And then my second one is already almost in slope-intercept form, -3x plus 2. So we would start at 2 and go down 3/1, down 3/1, down 3/1. And these lines are just about on top of each other. Well, notice that the slopes are the same. And if the slopes are the same, recall that that means the lines are parallel. And because the y-intercepts are different, those lines never intersect and there is no solution. So if the slopes are the same and the y-intercepts are different, you have parallel lines and they're never going to cross each other. So there is no solution. So then let's look at this second one. And it's a little trickier to graph. So let's solve for y again. 5y equals -2x minus 4 and divide both sides by 5. Y equals -2/5 x minus 4/5. And this is quite tricky to graph, but let's see what happens if we do a clever choice of an x. What if I do x is 3? Then I'd have y equals -2/5 times 3 minus 4/5. So that's -10/5 or -2. So 3, -2 is a point on this line. And once I find one point that's on the line, then I can use the slope down 2/5 to find more points on the line. Okay, so there's my first line. Whoops, missed it. Let me try that again. So that's line 1. Then the second line, if we write it in slope-intercept form, we're going to have y equals 3x minus 11. So here's -11. And up 3/1, up 3/1, and so on. And we draw the second line. And we observe that it looks like 3, -2 is a solution, but you must check. So you put 3 in for x in the first equation, and -2 for y, and you see that indeed that equals -4. And then 3 in for x in the first equation minus the -2, and that equals 11. So we have verified that 3, -2 is indeed the solution to this system of equations. It's the one and only point of intersection of these two lines. So you learned two ways of solving systems of equations algebraically. So let's just do a quick review of those. The first one is substitution, where you solve one of the equations for one of the variables. Doesn't matter which equation, doesn't matter which variable. And then we substitute that back into the other equation. So I kind of look and see if there's one that looks easier than the other. In this case, I don't think it really matters. So let's solve the second equation for y. So y would equal -x minus 3. Then I substitute that into the other equation. If you accidentally substitute it into the same equation you started with, you'll get 0 equals 0 and realize that you haven't made any progress. So now we have x minus 2x minus 6 equals -7. So negative x equals -1 and x equals 1. And then you have an equation right here that says how to find y if you know x. So y is -x minus 3 or -4. So 1, -4 is my solution. And then check your answers in both equations. It takes such a short time and you can catch little errors. So x is 1 plus 2 times y is -4. Yep, that equals -7. And 1 plus -4 equals -3. Now I'm quite sure that's my answer. Okay, then we also learned the addition method. So you're trying to make the coefficients of one of the letters be equal and opposite. So think about least common multiple. So for 5 and 3, the least common multiple is 15. So I'm going to multiply the first equation by -5 and the second equation by 3 so that I can get the x's to cancel, because I always add. I just make a lot fewer mistakes. So -15x plus 30y equals -10. And then 15x plus 12y equals 3. So the x's are going to cancel. I'm going to get 42y equals -7. Divide by 42 and get y equals -1/6. Nobody promised you integer answers. And then I can solve for y using either of the other two equations, because this solution has to make both equations true. So I have 3x plus 1 equals 2, 3x equals 1, and x equals 1/3. So 1/3 comma -1/6 is our solution, and you can check and make sure that it works in both equations. So that's the addition method. So let's talk a little bit about the language of systems of equations. If a system of equations has at least one solution, then the system is said to be consistent. If there's one and only one solution, we say the system is consistent and the equations are independent. If we end up with an infinite family of solutions, we say the system is consistent, but the equations are dependent. And then the other possibility is if we have no solution, the system is called inconsistent. So we should be able to identify those. Okay, so let's see what happens if we try and solve this system of equations using the addition method. So let me multiply both sides of the first equation by 3. So I'll have 3x minus 3y equals 15. Then I'm going to add that to the second equation, and I'm going to get 0 equals 17. What? So if you get something ridiculous that makes no sense, then there's no solution, and we have an inconsistent system. Okay, and then we'll do a couple more examples in another video so that they don't get too long.